All right. Oh, there we go. The sound's on. Welcome, everyone. It's great to see y'all at the Data and AI Summit 2024. We're excited to be here. We're going to get into this talk. The title of the talk is, It's Time to Make Your Lakehouse Universal. So I'm really excited. Thanks, everyone, for coming out to this session. It's great to meet some of you. My name is Kyle Weller. I'm head of product here at Onehouse. I've been in the data space for over 10 years, building data platforms, building data products. Right before joining Onehouse, I used to be a product lead for Azure Databricks. I was a Microsoft employee there and helped build the first versions of Azure Databricks. So very excited to be back at Data and AI Summit and see familiar faces, new faces, and have a good time here. So yeah, my name's Kyle, and Vinoth will jump in for us as well.
All right. Thanks for everyone for your time. My name is Vinoth. I'm founder CEO at Onehouse, we'll tell you about Onehouse, I guess, today. And I'm also the creator of Apache Hudi, one of the Lakehouse storage projects, and also on the PPMC for Apache Xtable. So quick show of hands, how many of you are familiar with the data lakehouse, or anybody not familiar with the data lakehouse, I guess? All right, and how many of you have built a data lakehouse already? And how many of you are thinking about building a data lakehouse? I guess, cool. All right, that sets us up really well. So if you are, you're generally familiar about the space, right? So before we go a little bit more, let's just take a minute to kind of like reflect kind of what's generally going on. If you've been tracking this space for a few years, or you're in this conference or the one last week, you generally hear a lot of things are going on and could be really confusing at some times to make sense of it. So let's take a minute, take stock of the story that has been playing for almost half a century here now. So if you look at it, right, from 80s, kind of we had relational databases were born. We had ones for OLTP, ones for OLAP, we're running in on-prem. And then the next real big wave here was rise of data science and machine learning as you know it. I used to work at LinkedIn when all this happened, the era of Hadoop, and a bunch of companies were born around that. Then we did one big move, which is a lot of things moved to the cloud instead of on-prem. And if you look at what happened over the last kind of like the pre-Lakehouse kind of thing here, the warehousing workloads just moved to like your cloud warehouses, and a lot of your on-prem data lakes just moved into the cloud, just like workloads just moved from on-prem to cloud. Now, if you look at it, there's a big convergence of the lake and the warehouse into some sort of like an open data lake house. That is what's unfolding in front of our eyes, and all warehouses now support a lakehouse architecture. Not so long ago, I gave like a talk on Lakehouse's warehouse when this is how we were talking about this in 2022, right? And this is the real shift that is going to now, control how we do data for the next few decades. So that's kind of like why, we're going to talk a lot of product and other things, but this is also why there's like a fair bit of learnings that we would like to share as well in terms of how to future-proof your data architecture and how to get this right. All right, so why is this happening? Fundamentally, warehouses aren't great for everything, right? So whether it be large volumes of, kind of like fast ingestion, mutable data sources or unstructured data, they're not great for everything. And there are purpose-built engines right now that are good at specific workloads, right? And fundamentally, one size doesn't fit all is an idea whose time has come and gone. I literally quoted like a Michael Stonebreaker paper, which talks about this phenomenon. Fundamentally, you have different workloads. There are specialized systems for each workload. And the scale at which we are dealing with data at this point, every 10% efficiency feature cost difference will give rise to a new system, right? Because the data is pretty massive, and you can do the basic math. 10% of $1 million cloud bill is still like a significant amount of money and functionality to be built, right? So we fundamentally, moved beyond that point. But what are users doing today? They are, we're adding new data platforms, right? So we start with the data warehouse, We start to do data science, ML, data engineering. Then we introduce a data lake. Then sometimes we're unhappy about our data warehouse. It's not fast enough. It's not really built for that kind of stuff. Then we introduce real-time data warehouses, right? Then we now starting to see this pattern of like a lake and a vector database being married in ways that, to build these like kind of like newer generation applications. This is great. The choice is great, but obviously you have massive wastage in a lot of cases in redundant data storage. There is redundant ELT, ETL pipelines on each platform. You need to make sure all of this is like consistent. And as you all know, building one high quality data platform is hard enough, right? So, this is where a better data lake can actually make a real difference. Because a lot of these workloads and the storage of it can actually converge on this kind of like a lakehouse architecture, while you still keep the engines kind of custom built for their individual workloads, right? And that's kind of like what we're going to talk about a little bit more. So is there a better way? If we told you no, we can all go home. It's like getting pretty late, but unfortunately, the answer is yes. So we'll probably have to stay in our seats for a little bit longer and talk through some of this, right? So I know we like talk about formats a lot in this space, and we like love our formats and stuff. But for us, the real light bulb moment here, when it comes to the data lakehouse, was this, which is for the first time we are able to get data of all shapes and sizes into a single platform. So just to put this in perspective, right? What typically went into a data warehouse was your lower throughput, mutable data sources can go sit there. Anything high volume, you put it on like a data lake, append-only data model. Now, the data lakehouse brought merge capabilities and higher throughput, and you could actually do both in a single converged platform. And this technical capabilities at the core of what's driving some of this like convergence. Now you don't need like two different systems. The data copying is eliminated and all of that, right? So, and of course you do this on open file table formats. You're decoupling them from engines. This really sets you up for like a really good foundation. This is kind of like a well-hidden industry secret right now, but we implied the world's first production data lakehouse at Uber way back in 2012 on top of this project called Apache Hudi. It continues to be like a really powerhouse open source project. We support like, a lot of big data lakes out there, right? So through this time, what we learned from those journeys was that, in addition to picking your formats and writing your jobs and stuff, you need actually like a thought out data architecture for you to kind of achieve these results, to reduce costs. And this is fundamentally what, I know some of this can be like super abstract and like, very, block diagrams connected by arrows and stuff. So let's make it like super concrete, right? Let's take one of these rows that we talked about in this table before. Just take Spark, just one engine in that like table. And if you look at it, there is so many vendors here that are offering Spark, right? And at different price performance, feature sets, and all of that. So you really need to like do your homework, make some, be smart about how you're setting up your data for interoperability so that you can switch compute vendors if needed and stuff, right? So this thing really matters. This is not a, like a good to have sort of like vitamin anymore. If you don't take this, you'll be in a lot of pain later on, right? So luckily over the last 6-7 years, we've kind of like seen this pattern with tons of these companies that we've worked in the open source community. And they end up in the same architectural pattern. We've given this a fancy name, and they're calling this the Universal Data Lakehouse. The idea is pretty simple. You ingest data pretty quickly. You keep up with your, fast enough that you can keep up with your operational systems, right? And you can bring data of any scale, size, or shape, right? Essentially low scale, but mutable, like, SAS sources or high scale event streams or kind of like NoSQL stores or anything really. And then store it in open formats. And you have like, invest in broad interoperability. For example, like, probably Kyle will cover this more. Xtable brings that interoperability across the entire ecosystem. no one engine is going to be the end game here, right? So instead of investing in unification, we invest more in interoperability. Then whatever you ingested, you process incrementally pretty quickly, right? So if you don't do this, what happens is somebody will start like cutting this thing and build another silo up before that, and you can query this data anywhere across multiple catalogs. Each engine's like pretty married to their catalog and for good technical reasons. So cross-engine, cross-catalog support to access your data and centralize the management, right? So GDPR deletions, things like that. You want to do it once in a single place. Rewriting a lot of data and deleting them is not a simple operation. It's pretty expensive, right? So if you set it up this way, and it's been like a pretty battle-tested approach that we've seen behind some of the most successful data teams out there. If you look at the open source users like Walmart, Zoom, TikTok, and Robinhood, and like bunch of people who have implemented this, I've seen like some pretty incredible success, right? So as simple as it is, it reads some really good results for you. So instead of having silos where data is stored in disparate platforms and constant data copying, you have one open data layer with interoperability, which means new engines can come up and you can adapt them quickly as well, right? And you have a single streamlined entry point for data. Instead of each copy of this data being limited to specific engine, restricted implementations, even on top of open source formats, you have you can use any major lake engine warehouse, adapt new engines, as I said, right? And for these modern workloads, right, some of these warehouses are not built for data lake scale and volumes, right, generally speaking. So you can, if you pick your Lakehouse storage, carefully, you can even get minute level freshness, even for the most complex workload patterns. And the other interesting kind of silo that usually gets built is, I need a streaming data copy. So you can do minute level freshness. It eliminates a lot of that streaming silo, if you will, right? Specialized copies for just data freshness, right? And a lot of this, technologies, especially warehouses, scale kind of poorly with data volume or expensive mergers, do pretty much batch processing, right? Moving them more to a incremental model or offloading some of this ELT, ETL costs, right? You're doing that ELT, ETL pipelines once across all the systems that you're doing. So you're moving from premium compute to more standard compute that you can use. You can save a lot by just in this process, right? So just to kind of cap this off, before I hand this off to Kyle, just a simple case study, right? In open source from, if you know Notion, right? They had this architecture where they went from using a warehouse. They started with a warehouse for everything else, right? And then you start to build your AA products and stuff like that. Your workloads are different, right? Then they went through this process of kind of moving from a vertical close, a single warehouse model into this kind of a universal data architecture where they're now able to pick the right engine for the right workloads, right? So the warehouses are still good, fun, great for BI, while you can bring the power of Spark and things for other modern workloads. You save a ton of money, gain a lot of latency, and unlock some new use cases, right? So this is our general principle behind what we build and what we are trying to bring towards here with Onehouse. And with that, I'll hand this off to Kyle to take it from there.
So with this beautiful architecture that Vinoth just described, let's talk about how do we actually get there, and let's start making it real into some traction. So I've seen, as Vinoth describes his experience in working with so many folks out in the open source community, and he's the creator of Apache Hudi, a very popular open source Lakehouse table format. I've also been building multiple data products around the data lakehouse space, and I've seen firsthand how challenging it is to try to achieve this type of vision and to achieve this vision of being universal. Now, some of the key characteristics where I see folks fall short, one of these is when they start to make their decisions to start from the query engine. And they look across the vendor ecosystem and they say, all right, this vendor has a great, strong roadmap. It looks like they'll be able to solve the problem that I have. Let's start there and then work backwards. When you start from the query engine vendor itself, each of these query engines builds a vertical optimized stack that is designed to drive retention into their compute vehicle. They want to keep that workload with their engine for as long as possible. What Vinoth motivated at the beginning when we looked at, you have a diversity of workloads, a diversity of workload types and shapes and patterns, and you will want to have also the ability and flexibility to mix and match your query engines to match those workload shapes, right? So if you start your decision of what your data architecture looks like from the query engine, that's not a great place to start. Just as equally, if you start, when you look, because that's starting from like the top down is what I might describe. But now if you think about, all right, I'm gonna start from where my data is born. Your highest value data is not born inside of a data lake itself. Your data that's generated from your line of business applications or IoT sensors or wherever that data is coming from, originating from, it lands somewhere before the lake and you have to ingest it, replicate it, change data capture, bring this data into the data lake for your query engines to be able to process and make use of. So also starting from that beginning principles, you want to pick an ingestion service that is open and sets you up for that interoperable universal architecture. So examples like I have on the screen here, just like that use case that Vinoth called out of Notion, previously using something like a 5-tran direct ingestion into Snowflake. Now all that data is married to Snowflake, and Snowflake can, it's a great product, and it can cover a lot of use cases, but Notion had additional use cases. They had to build Notion AI, if any of you have used some of the new AI features inside their notebooks. And so they recognized that because of these different workload patterns and new business goals that they had, they needed to be in a more flexible architecture. And that's why they picked to move to Apache Hudi and store this data inside of a data lakehouse on cloud storage itself. Similarly, there's lots of data ingestion, data integration tools out there. Even just a brand new one that had a press release this morning from Databricks called Lakeflow. And I'm sure there'll be more discussions about it through the conference this week. But again, that's ingestion to a specific query engine itself. Now, this last point here that I have on the screen, it says interoperability is more powerful than unification, okay? So unification is great and it gets you so far, but interoperability ultimately gives you the power to choose and have flexibility to keep your data safeguarded and future-proof, okay? So one area that our team has innovated and worked hard is in the creation of this brand new open source project that's called Apache Xtable. How many folks in the room have heard about our new open source project? Oh, a fair number of you, nice, okay, great. And maybe that's why you came to our session, maybe you've heard about this project or been interested in learning about what we're doing in this space. So Apache Xtable, we actually created this new technology last year, and then we co-launched it with Microsoft and Google. After we co-launched it as an open source project, then we donated it to the Apache Software Foundation. And what it is, if I advance one more time here, the clicker's not working too well, but how it works and what it is under the hood is, Delta Lake, Apache Iceberg, Apache Hudi, all of these Lakehouse table formats, at least they all agree on Parquet files as being the underlying foundation. So they all have Parquet files, and they have a specialized metadata layers that they put on top. Delta Lake has a transaction log that's in a JSON format. Iceberg has manifest files in these Avro manifests. And Apache Hudi has a special timeline as well, and you'll see it represented in cloud storage as this .hudi folder inside there. Now, when you have your underlying foundation of data in Parquet, we can very easily interop from one table format to the other in a lightweight, incremental fashion. And now your table, you see this on the right-hand side, this is what your S3 storage would look like on the ground. You would have a Delta Lake transaction log side by side, the Iceberg manifest file side by side, the Hudi timeline as well. And it's a very powerful technology. Now, since we open sourced and donated this to the Apache Software Foundation just recently, now this has been growing a lot of speed and momentum. And it's great to see contributors, users, mentors. Even now, just in this last month, Databricks and Snowflake have jumped on board onto this project as well. And we also collaborate with Databricks across the aisle with Delta Lake Uniform. If you've heard of Apache Xtable, you likely heard of Uniform as well. And so we actively collaborate across these two projects. We share code and we co-develop. Our goals are the same, to have interoperability across these table formats. So that's there. But it's great to have folks like alongside where we initially launched with Microsoft, Google, Databricks, Snowflake, of course ourselves, Adobe, Dremio, Cloudera, Walmart. This GitHub repo is in a special place inside the Apache Software Foundation where if you understand governance structures around open source projects, this is in a place where no one vendor even has like admin access to the GitHub repo, and no one vendor has even like trademark or legal rights to the project anymore. It's completely governed and owned wholly by the Apache Software Foundation. It's incubating, it's in the incubation program of the Apache Software Foundation. So great, now we've set up interoperability across Lakehouse table formats, which make up that core foundation of what your data lakehouse is. And now we're gonna talk about what our product is and how we offer these. If you want to learn more about Apache Xtable, that project, and see deeper dive demos, I'm actually delivering another talk on that tomorrow at 5 p.m. So look up my name inside the session catalog, and you'll find that additional session. We'll talk more just about open source details there as well. So if we flip to the next slide, we'll look at our product and the underlying details behind Onehouse and how we are delivering this in a fully managed way. So now this universal data lakehouse, on the farthest right-hand side of the screen, we start from data sources. And like I mentioned, your data is born in things that log it into transactional databases, MySQL, Mongo, Postgres, or event streams like Kafka or Pulsar. Now, Onehouse offers a fully managed data ingestion flow, and we will continuously ingest from all of these sources you see on the screen and more. We'll rapidly ingest that data with low latency, write this into Delta Lake, Apache Hudi, or Iceberg tables for you. Now, when we write it into these Lakehouse table formats, we don't just stop there. Now we add advanced optimizations around the table formats. Like if you've used or studied the table formats, you've likely heard of characteristics around file sizing, clustering, cleaning, compaction. We offer all of these standard features, but we've innovated even further beyond where it is with open source to add even things like full indexing subsystems and more beyond this. After we perform all these optimizations, you also can express incremental transformations and build full multi-stage ETL pipelines with Onehouse. And so alongside this, then at the final stage, we have a multi-catalog synchronization process. And so what this means is, because to truly plug in to the diverse set of query engines that are on the map there, you have, unfortunately, an ecosystem of multiple catalogs out there today. You have things like, of course, the Hive Metastore, which is like the most prevalent out there in the industry. You have new things like Unity Catalog, and it's very exciting to see Unity Catalog finally becoming open source this year at the conference here today, if you went to the keynote this morning. You have things like Snowflake just announced their Polaris Catalog. And each cloud vendor and kind of each query engine themselves has their own catalog. At Onehouse, we have a multi-catalog synchronization tool that allows you, as you're rapidly ingesting this data, well optimizing it, so it's analytics ready. Now we've synchronized it to all the catalogs. Now you can just crack open Databricks Notebook, you can crack open Snowflake, you can crack open Starburst from Trino, and all your tables are available. And ready for analytics, ready for AI, ready for training your models. From there, there's three main ways that you can use our product. One is like a fully managed ingestion flow where you can have like auto-scaling infrastructure that is serverless deployed inside of your VPC. And from there, you have a nice UI. I'll show you a demo. and you have APIs available, that you get this low-code, easy experience to build all of your pipelines and manage these. We also have a mode that you can use our product in, where if you already have pipelines where you're writing Delta Lake tables, you're writing Apache Hudi tables, Iceberg tables, and you want to leave your writers alone, you want to leave these compute services alone, we can come in because we have innovated on top of these Lakehouse table formats. We can come in and add Lakehouse table management, some no-knobs tuning experiences, and intelligent automatic optimizations that adapt based on your workload patterns that allow us to squeeze out an additional 10x performance and cost savings on top of your Lakehouse table formats that you might have. And in a third way, if you wanted to get started in a very easy way, we also offer a full Lakehouse observability platform as well, where in a lightweight way, you don't inject any compute services. We can just monitor the tables in place as they are, and we can build insights and recommendations to you of what those tuning and optimizations might be. So then you could choose to take those insights and go implement them yourselves, or you could choose if you wanted to engage with Onehouse further from there. Great. I'm going to zoom through a couple of these slides because based off of the time, I want to show you real live actual demo. I'll just show you a couple highlights of features and the details behind these features. So when it comes to fully managed ingestion services, if you have streaming sources, we have things like multi-regional ingestion flows from Kafka, topic monitoring and auto capture functionality. We have ways to really innovate and bring great experiences to streaming data and low latency ingestion. We do full change data capture. This means not only do we extract the change logs out of the databases, but we will materialize those changes inside of your tables on S3 in Apache Hudi, Delta Lake, or Iceberg tables. And of course, we can ingest from cloud storage locations themselves. As I zoom through here, we have a full low-code ETL pipeline which you can build transformations and multi-stage pipelines. I'm going to zoom on a couple of these slides to get to demo. We have data quality quarantine mechanisms where you can be able to protect yourself from upstream schema changes that might have broken your pipelines otherwise. Everything that you'll see in my demo today on the UI is also available via APIs. So you can create templates for all of your pipelines, check these into version control systems, and we have customers today that will auto-deploy hundreds of pipelines and manage these simultaneously. We talked about the multi-catalog synchronization tool that we offer. One important slide before we get into the demo as well, all of the infrastructure that we deploy is deployed inside of your VPC, inside of your private network, so your data never leaves your account. And this is something unique related to other data integration or ingestion products that you might see out on the market today. The end result is seeing a unified data lakehouse experience that offers all these services I'll show you in a demo. In the other path, like if you were using Delta Lake or Iceberg or Apache Hudi on their own, you might be in a place where you're continuously monitoring and tuning your pipelines, or you might be in a place where you are spending a lot of on-call burden and operation and ops to manage these pipelines. Let me switch my presentation mode to actually look at a live demo. Okay, I need to grab this from Chrome. And I see, because my window is extended, I'm over here. Okay, can I flip to mirror mode? Okay, I'm going to change to mirror. I just have to get my mouse over here. Perfect. And screen mirroring to mirror this one. Yes, demo time. Oh, I see. Okay, I will, oh, this works. I can look at it down below. All right, apologies for the small interruption. We are good to go on the demo now here. Okay. And the recording's still working for this as well, yeah? Okay, perfect. Okay, so I'll give you a walkthrough of what an end-to-end flow would look like if you were to choose to use Onehouse to build a universal data lakehouse. Now, the scenario here, I've got some retail data that I have in Postgres, and I also have like real-time transactions flowing through Confluent Kafka, okay? When you come inside the Onehouse environment, let me put this in full screen. When you come inside Onehouse, one of the first operations that you might want to do is configure your data sources. So for this demo, I mentioned I have Kafka, Postgres, even some S3. The way you would configure these sources, you come in here to add new source, and you say, all right, which flavor of Kafka might I be using, or which database might I be using? And I can come in here and add the connection details as you might expect. We also have ways to natively integrate into the secret manager inside of your native cloud as well. So it's very easy to integrate those sensitive credentials. Now, after you've defined the sources, you have the list of sources available, and you can start to build pipelines. So I will come to what we call stream captures and say, let's build a new pipeline. I'll grab data from Postgres, and now I can choose my write modes, whether this is append only, or of course from Postgres, I may want to apply the mutations, updates, and deletes from my database into Apache Hudi tables on S3. I choose my sync frequency. Now I can choose which tables I would like to ingest into my lakehouse. Inside here, you can apply advanced optimizations. We mentioned things about our data quality quarantine mechanisms. You can add low-code transformations. Maybe I want to add some data masking to a field that I think might be sensitive. Maybe it is one of these fields that I think is sensitive here, and I can add this masking operation. This right here is indicating that it auto-detected that I was using a Postgres source, and under the hood, we are automating even infrastructure like Debezium and Kafka for you, such that you can, we can extract the change logs in a very lightweight incremental processing way to apply these upserts or updates and deletes inside of your Lakehouse tables. You can add primary keys, partition keys, these kind of things. You choose a destination. This is basically your S3 bucket, the lake and folder path where you would like it to land. And you can synchronize to multiple catalogs simultaneously inside here. When the pipeline's running, you'll be able to inspect or monitor any of these pipelines, and you can see how much data is being ingested in near real time. You can get into logs if you're interested, and these details. All of the data is available to browse inside of here, where I have a concept of lake database tables. This table right here, you can see how it's been building over time. You can see the upserts, inserts, deletes as they've landed. You can apply advanced optimizations if you want to change any default settings. Let's say that you've read about the Z-order clustering strategies and you want a multidimensional, you can even pick a multi-key clustering strategy inside here. Or you want to modify your compaction settings or cleaning settings. Now your tables are well optimized and synchronized to the catalogs that you indicated. So whether this is Snowflake directly, an HMS external system, Data Hub, you name it, we'll be synchronizing to these catalogs, such that once the data lands, now you can just open something like Snowflake and you can see your Onehouse tables synchronized, ready to go. Or Databricks, you can crack open your notebooks here and have all the tables registered into the Unity catalog available for analytics, data science, ML, AI, and use all of the great innovations that you've learned about at this conference as well. With that, let me come back here to the final piece. I think if I put it in there, that will work. Okay, so that concludes our demo here. And I want to leave you with just two last things before we open up for some questions. Onehouse, we are a startup company, and we are moving very fast. We, of course, are building on top of battle-tested, proven open source technology that is used to build some of the largest data lakes on this planet. Now we've assembled the team of experts that have been operating and building these technologies under the hood for many years. So we've been engaging with customers now across many different industry verticals, and building some pretty amazing use cases. So you can see a couple examples here, like in the retail space, on us doing real-time ingestion from IoT sensors or retail and orders and inventory management, utility companies, fintech companies, and now our product is gaining a lot of traction and working with diverse workloads and massive scale workloads. We even have a customer, you see the example here, that reached up to a 1.5 terabyte per minute peak per burst processing rates inside there. So we are now on top of this battle-tested open source technology. Now we're building a product that can really operationalize and bring this to companies that are trying to build data lakehouses at this scale, but maybe they don't quite have the time or the talent, or maybe they would rather spend their efforts and initiatives on higher value activities, maybe leveraging more of Databricks' AI capabilities that you guys just learned about inside this conference here today as well. So for Onehouse, we offer very generous free trials. If any of this interests you, or if you have use cases that seem relevant to what you heard earlier, we'd love to chat with you and let you try out our product. And we think it's very easy to, in a few days, you can be up and running, and then you can make a decision. Maybe you like us, maybe you don't. But we'd love to engage and discuss with you, even about if it's architectural questions and decisions. We'd love to have a conversation. So reach out to us at any of these handles here, or stick around, and we'd love to even engage with you after this session. I thank everyone for coming to the session. Thank you so much. We really appreciate your time, and let's continue the discussion. We'd love to chat with more of you here. Come see my other session tomorrow, 5 o'clock. I'll be presenting with Dipankar, who's someone that's been influential building the Iceberg community as well. And so we'll have a good time talking more about Xstable in detail here. So keep in touch, and thank you.